guys. My name is Desmond, and I welcome you to my lesson for today, where we will be looking at mathematics. Obviously, as you can see over there, trigonometry is what we will be looking at in today's lesson. So, ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important, because what I'm about to say, it's massively, massive. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please, honorable members, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies. So, obviously, yes, when was it? I think last week on Saturday, we started with this chapter called Trigonometry. So, very quickly, I'm going to take you through what we have done in preparation to the question paper that we will be looking at in today's lesson. Most importantly, this part won't be where you guys will interact, but I'm just going to quickly take you through the units that I've discussed, and then from there, we will then engage as we look at the question paper. So this is what we discussed. Remember, trigonometry, in simple terms, we actually look at the relationship between the sides and angles. So we are actually studying a triangle. So remember, this is a triangle. This is a triangle. But under trigonometry, it's not just any triangle that we are looking for. For example, okay, this is a triangle, this is also a triangle, but you might find that between these two triangles, this one, it has got that sign. It is therefore not just a triangle, but it is what we call a right-angled triangle. So now that means we erase that, and this is what we will be looking at. So that means under trigonometry, we study what we call a right-angled triangle, which is an angle that has a 90-degree inside. So most importantly, under a right-angled triangle, we said each side has a specific name, and those names were three. Remember, guys, under trigonometry, we are only focusing on three things, which is, let's see, we are actually looking at three sides and three angles. So it's just a game of three things. And these sides have got the names, and the names are called hypotenuse. We also have the other name called opposite, and the other name called adjacent. Remember, guys, this was just an introduction in preparation to exam questions. So if you guys remember, I said this is just a triangle. It's not a right-angled triangle. It is just a triangle having three sides and three angles. Someone might say it looks like a right-angled triangle. Yes, it does. But because we did not tell you that it is a right-angled triangle, it is not. It's only a right-angled triangle the moment you see that. Or if you were told in the statement to say, this is a right-angled triangle. Therefore, because now we are 100% sure because of that sign, we know it is a right-angled triangle. Therefore means this side has got a name, that side has got a name, and that side has got a name. The question is, which one is hypotenuse? At all the times, we know hypotenuse, it is the side which is opposite to your 90-degree angle. Let's say we've got A, B, and C. So that means AC is what we call a hypotenuse. So now, which side is adjacent and which side is opposite? At this stage, you cannot tell which side is adjacent, which side is opposite. Why is it that at this stage you can't tell which side is which? Because you are not given the reference angle. You can only tell which side is which regarding opposite and adjacent only if you have the reference angle, which could be an angle there or an angle there. If I now say this is your reference angle, that's when you will know that this side is the one which is adjacent, and then the side opposite to the reference angle is called opposite. So very much quickly, if I do this and I say, is this a right angled triangle? An answer to that question, it's a big no. Why? Because we are not told and we can't see a proof, or we can't see any confirmation that this is a right angled triangle. But the moment I do that, you know it is a right angled triangle. Therefore, the side opposite to your 90-degree is your hypotenuse. Between these two sides, you cannot tell which one is adjacent, which one is opposite, unless if I say you've got an angle there, then you know this is the side which is adjacent, and the side opposite to the reference angle, it is opposite. So very, very much important that you are able to notice which side is which. So now I think under unit number 2, this is what we discussed. Let me quickly check my notes. So under unit number 2, we discussed what we call trigonometric ratios and their reciprocals. This is me trying to summarize all that we did last weekend. So if you guys remember, we said we are only dealing with what we call a right angled triangle having 3 sides and 3 angles. Remember, trigonometry, the study of a triangle. We actually study the relationship between the 3 sides and the 3 angles. So now we have what we call the trigonometric ratio. So every time when you hear me saying trigonometric ratios, I'll be talking about sine, cos, and tan. These are what we call the trigonometric ratios. So maybe very quickly, let me introduce what we call the reciprocals. Remember, guys, the word ratio, it means something over something. So now, these are what we call the trigonometric ratios. So the ratio meaning sine is opposite over adjacent. So it's more like it's actually the ratio of the sides of a triangle. I know very well that you are aware of what I'm explaining right now, and I think you guys cramped it as SOHCAHTOA, where cos is adjacent over wait. I just noticed I made a mistake somewhere. So let's see. Sine opposite over hypotenuse, sinoa, or SOHCAHTOA. So this is actually tan and not sine. So I'll just quickly have to correct that and say sine is opposite over hypotenuse. So that is the trig ratio for sine. And then when it comes to cos, it's adjacent over a hypotenuse, cosine, adjacent over hypotenuse. And then tan is tanua, meaning opposite over adjacent. So I'm just trying to quickly go through all of this so that we get to the business of the day. Remember, guys, all that I'm explaining in today's lesson, it was done last week, Saturday. That's when we started with this chapter of trigonometry. So for now, please do allow me to just quickly go through this introduction. Before we start with the business of the day, I'm going to give you guys an opportunity to ask any questions based on what I've explained. And then from there, that's when we can start with our question for today. So now the reciprocals. What are the reciprocals? If you remember, the reciprocals refers to the inverse of your trigonometric ratios. So the reciprocals, that's when we talk about sec, cosec, and also cot. So maybe let me try to remove all of these and say trigonometric ratios. Let's say we have sine, cos, and then we have tan. And then in terms of the reciprocals, let's say we have a cosec, and then we have maybe cot, and then we have a sec. So we now need to know what is the cousin of sine, what is the cousin of cos, what is the cousin of tan. So this is how you remember. You focus on letter number 3 on this. Let's see, what is letter number 3? 1, 2, 3. Can you see letter number 3 is S, meaning S for sine. So which means cosec is the cousin of sine. Maybe let me continue to say, when it comes to this one, what is letter number 3? 1, 2, 3 is T. So you see, that means T for tan. So that means the cousin of tan is cot. And then now let's look at this one. What is letter number 3? 1, 2, 3 is C. C for cos, meaning the cousin for sec is a cos. So why is it important for you to know whose cousin is who? So let's see. Remember, sine, the trig ratio for sine, we say it's opposite over hypotenuse. And then for cos, we say it's adjacent over hypotenuse. And then for what? For tan is opposite over adjacent. So now, with you understanding that you have, let's say, cosec, sec, and you also have a cot. So cosec, since is the cousin of sine, that means the ratio for cosec, you just swap that. The denominator becomes the numerator becomes the denominator. So that means it's going to be a hype over opposite. Similarly, for sec, it is the cousin of cos. So you just swap those. Let's see, that means it's going to be a hypotenuse over adjacent. And then for what is it? Cot, T for tan. Let's see, that means you end up having adjacent over opposite. It's going to make some sense when we start answering exam questions. Sometimes your teacher might say cosec, it is the same as 1 over its cousin. What is the cousin of cosec? It is sine. So it still refers to one and the same thing. Similarly with sec, they can say sec is actually equals to 1 over its cousin. What is the cousin of sec? Let's see, it's cos. So it's going to be cos. And then that, it's going to be 1 over the cousin of cot being tan. So if you substitute the ratio of sine being opposite over adjacent and you simplify, it's going to take you back to this ratio. Similarly, when you do that, it's going to take you back to that ratio. And also for 1 over tan, if you substitute that ratio being at opposite over adjacent, it's going to take you to that ratio. So that's what we discussed under unit number 2. Very quickly, let me take you through what we discussed under unit number 3. Let me maybe write it there. Say under unit number 3, this is what we discussed, the special angles. That's what we discussed under unit number 3. To say the moment examiner says special angle, you remember 30 degrees, 45 degrees, and 60 degrees. For now, we discussed only those. So obviously you have, let's maybe start with the special angle for 45 degrees. You need to always remember this. You need to know it by heart. It is always where you might find 45 there. If 45 is there, you have 90 there. For you to have interior angles being equals to 180 degrees, that means that angle is also 45 there. So that is why you can either have your 1 there or you can have your 1 there, where your hypotenuse is the square root of 2. So that means the moment you're dealing with a special angle of 45 degrees, your adjacent or opposite, it's equals to 1. So how did they get that square root of 2? If you remember, what is it? Theorem of Pythagoras. Your adjacent is 1 and then your opposite is 1, is equals to that. So this plus that, you end up having 2. So you therefore remove that squared and you end up having your r being your hypotenuse being equals to a square root of 2. So that's where that square root of 2 comes from. So the same calculation can be performed in order to determine the sides for the 30 and 60 special angles. So this is what happens for the special angle of 30 degrees being at that angle there. You have your 1 being opposite that 30, you have your square root of 3, and then you can still use the theorem of Pythagoras. You will get 2 there. And then very quickly, let's have a look at that special angle of 60 degrees. So 60 being there. You still have exactly that arrangement. Your adjacent being that, your opposite being that, and then your hypotenuse being that. Then what they realized is that, okay, it seems like what differs between these two is the position of the angle. Let's maybe try to save some ink and combine these two into 1. Let's see, with 60 being there and then 30 being there, you will still have your adjacent being there, adjacent to 60, opposite to 30. So that means this is the position of that 1, and then this is the position of square root of 3, and this is where you have 2. So instead of you trying to redraw this, you can save some ink and just draw it as a combined triangle. So remember, guys, at all the times, you need to always remember this. I don't think it's given to you on the formula sheet. So it is very much important that you know that by heart. So I think just to summarize all that I've explained, as far as right-angled triangle is concerned, you also need to remember this formula, which is the theorem of Pythagoras. So in summary, this is what I'm going to be using in most cases. Theorem of Pythagoras, trigonometric ratios being the sine, cos, tan, and also the reciprocals, which could be cot, sec, and then cosec. So this is what you need to always remember and understand, because you might need to use those, or you might be given these and you might need to convert them to those so that you can answer whatever question that you'll be asked. And lastly, guys, a right-angled triangle can be drawn on a Cartesian plane. What is a Cartesian plane? A Cartesian plane has got what we call the x and the y-axis. And remember, how many quarters does a Cartesian plane have? Just like an orange, if you cut it in that manner, you have this being quarter number 1, quarter number 2, quarter number 3, quarter number 4. So that is why we call this part a quadrant number 1, meaning it's quarter number 1, this one is quadrant number 2, this is quadrant number 3, this is quadrant number 4. And we do know very well that here along that x-axis we've got an angle being 0, and then that angle from 0, it increase up to that angle being 90 degrees. From there, it increase up to there. Then this is that angle being 180 degrees. And then it increase up to there, being 70. Increase up to there, being 360 degrees. So now a right-angled triangle, it can be drawn either in the first, second, third, or fourth quadrant. Let's try to look at how it looks like in the first quadrant. So it starts from the origin. Remember, the origin, it is that point where your x and your y-axis intercept. So we have that line called the terminal side. But just to keep it short and simple, this is our radius, or if you like, this is our hypotenuse. So now to form a right-angled triangle, that's if we draw that vertical line which is parallel to that, forming a 90-degree angle there. So now we realize that this is the angle. And then that means this side of the x-axis is our adjacent. And then the y, what is it? That side which is opposite to the angle, it's what we call the opposite. In terms of x and y, we refer to that as y. So that means under trigonometry, the moment we talk about y, remember opposite. The moment we talk about x, remember adjacent. The moment we talk about the radius or r or the terminal side, remember hypotenuse. So that means for all these triangles that I'm going to be drawing in each, in each quadrant, this will always be my x, or otherwise adjacent, and obviously this one a hypotenuse, and then this will be a y. And then now this triangle in this quadrant, we are still having our x as that, this one obviously y, and then this one becomes your r, otherwise your hypotenuse. And then that one there, can you guys see, this is your y and this is your r, or your hypotenuse. Something that I've also discussed with you guys last week, I said at all the times, your r is always positive. Your r is always positive. Your r is always positive. But when it comes to x and y, it all depends on the quadrant in which your right-angled triangle is drawn. I'm pretty much sure that you guys are aware that from the origin going to the right and upwards to the right, positive x values, upwards, positive y values. So from there, in that direction, you have negative x values, and then going upwards you have positive y values. But from there going downwards you have negative y values. You still have negative x values there, so that means also here you're still having negative y values. So you will realize that when we talk about sine, of which we know that sine angle, it's equals to what? Opposite over hypotenuse. Already you know that your hypotenuse is going to be that positive r. But when it comes to your positive, you ask yourself this question: in which quadrant is the right-angled triangle drawn? Is it in the first, second, third, or fourth? Let's maybe make an assumption that it's in the third quadrant. So ask yourself this question. Since we said opposite, we remember y, this one R. Is your Y in that quadrant positive or negative? You can see your Y is negative. That is why you are going to have a ratio which is negative Y over R. You can still ask yourself the same question when it comes to tan and also when it comes to cos. You know your R at all the times will be positive, but when it comes to your X or otherwise your Y, ask yourself this question: in which quadrant is the triangle drawn? Examiner can try to be smart and give you a range to say your triangle is possibly or it's between a 0 angle and 180 degrees angle. So that means you need to use your tricks to find out whether it's in the first or second quadrant, which is something that you might learn at a later stage when we start answering exam questions. I think I've tried to cover in summary all that we have done last week. So I just want to check if there are any questions before I start with the business of the day. So that was just me being very, very fast trying to summarize all that we learned last week. So before we start with the business of the day, anyone who's got a question? I see Mapasika is on the line. Apelele Precious. Kwazi the Makwazis. Are you sure, honorable member, you don't have a question? Are we on the same page on what I've just explained?
We are on the same page, sir.
Umidama Umis. Are we on the same page, honorable member?
Yes, sir.
Okay, I think you are one of those who attended that lesson. So that was me just trying to summarize. So let's now try to work out the problem that was sent in the group. Okay, question number 4. So remember, Umi, everything has got a starting point. So you might be in grade 11, you might be in grade 12, struggling with trigonometry. I'm telling you guys, if you are in grade 11 or 12 and struggling with trigonometry, it's not like the grade 12 trigonometry is difficult. It could be that you missed an important information in grade 10. So that means grade 10 it's actually the starting point. So do not neglect the information that was taught to you in the previous grades. Make sure that before you worry that much about the grade 11 or 12 content, you still remember and fully understand what you've learned in grade 10. Otherwise, if you forgot, that's where we will start you and then gradually move on to some complicated questions. So I'm pretty much sure that you guys saw this, which was sent in the group. 4 chord angle plus 3 being equals to 0, and where they say that angle is between 0 and 180 degrees. Remember, guys, when something is written in this manner, it means this, which is written in between, whatever that it is, it's actually between 0 and 180 degrees. So now, 4.1.1, they say use a sketch to determine the value of the following. In capital letters, do not use a calculator. So this is what you are given, the UMIS. And they say use a sketch to determine the value of the following. Do not use a calculator. So when it comes to this type of questions, them are UMIS. Very, very much important that you complete your right-angled triangle. This is where you need to remember that, okay, they're saying your right-angled triangle lies between 0 and 180 degrees. So that means you are only focusing between 0 and 180 degrees. So that means your right-angled triangle, it's either is here or otherwise it's either is there. So the question is, how are you going to know in which a quadrant your triangle lies in? That's why I always say, whatever that you are given, try to rewrite it as a trig ratio of either a sine something, cos something, or tan something. But can you see, it's given to you in that format. So let's maybe try to rewrite it nicely. What do I mean by rewriting it nicely? So it's more like, let's try to convert that chord to a trigonometric ratio. So that's why you need to remember, what is the cousin of a chord? I think it's tan. But most importantly, let's follow the correct procedure. What happens is, whatever that is given to you, whether it is a trigonometric ratio or a reciprocal, remember, trigonometric ratio, it's either it's sine, cos, or tan. Reciprocal is either is cot, cosec, or sec. So that means it's given to you as a reciprocal. So what you need to do is to isolate that trig ratio or a reciprocal. What do I mean by that? Let's move everything away from that. So that means you are actually going to have this being taken to the other side. So it's going to be -3. You need to remove that 4. That is why you're going to divide both sides by 4 so that it cancels. And you end up having your chord angle, which is equals to negative that over that. But wait, before I go deep, do you guys understand what I've done there, or what I've explained where I ended up getting to that point? It's not like this is the final answer, it's done. But I just want to understand, do you guys understand what I've just explained there? Remember, in case if you've got no idea of what I've done, make sure that you do not allow me to continue until you understand. Everything in maths has got an explanation, and everything has to make sense. If it doesn't make sense, it could be because you missed my introduction, or you attended a bit late, or whatever. But most importantly, do you guys understand what I've done there? Does it make sense to everyone?
It makes sense.
Silence in court. Okay, I just got a response from someone saying it makes sense. So remember, guys, sometimes it does happen that I say something now, but you get it after a few seconds. So sometimes there's that delay. But most importantly, in case if I ask a question and you get the question, if you've got no idea, please make sure to say no idea, so that I'm aware you did get my question, but you've got no idea. I see we've got Asa on the line. Asa, does it make sense what I've just explained there, honorable member? Mapasika, are we okay that side?
Yes,
Yeah,
it
yes,
does
we are
make
fine.
Okay, 100%. So remember, we said the cousin of a chord is tan. And we do know very well that if you want to move from chord to tan, you need to work out that ratio by swapping that becoming that and that becoming that. Meaning, if you now want to convert that, what we call the reciprocal, into the trigonometric ratio, that means you will then need to swap those and have 4 at the top and then you have 3 at the bottom. But remember, the sign remains as it is, of which in that case is negative. So that means you do remember that the ratio for tan is actually opposite over adjacent. In terms of x and y, that means the opposite is y, and then the adjacent is x. So this negative, it doesn't mean it belongs to 4. It doesn't mean it belongs to 3. Also at this stage, you cannot make a conclusion to say that negative belongs to 3 or it belongs to 4. What guides you is at this stage where you know you've converted your reciprocal to a trig ratio. Then you ask yourself this question. In which quadrant are you going to have your right-angled triangle? You do know very well that in this quadrant, both the y and x are positive. So already it fails to be in that quadrant. It has to be in that quadrant where you know there's that a 90-degree angle there, and then there is your angle theta, and then now you need to decide this negative, is it for y or is it for x? Then you do know very well that in this quadrant, your y is a positive. Yes, your y is positive, and then it is your x which is negative, meaning that negative actually belongs to x. In some instances, it might belong to a y. Obviously, that's if you have your thing in that quadrant where you know your y is negative, but your x is positive. So now you have your x there being negative 3. Remember, guys, remember, with this type of questions, what you need to do is to make sure that you've got whatever given in the trigonometric ratio. And then secondly, you draw your sketch and then you complete your sketch. Once you have done that, that's when you can have a look at the questions. But before you've done all of that, do not look at the questions. So this is what I used to say. I used to say, make sure that you have your ratio as sine, cos, or tan. Once that is done, then complete your right-angled triangle. When I say complete it, I mean determine in which quadrant it is. And this gives you a hint to say it's either it's in this quadrant or that quadrant, or it's either it's in that quadrant or that quadrant. If they want to say it's either it's in those two quadrants, they're going to say your angle is between 180 degrees and 360 degrees. So otherwise, if they want to say it's between those, they're going to say between 90 and 270 degrees. Then you follow the same procedure to try and find out which one is negative, which one is positive, and also if it's given as a reciprocal, try to convert it to a trigonometric ratio. So now let's try to complete our right-angled triangle. This is where now you need to introduce your theorem of Pythagoras. So obviously your x, it is what? It is 3. So it's more like you're saying 3 squared plus 4 squared, it's equals to r squared. And then now, obviously, you end up having all of that being equals to your r. So that's how you easily calculate your r. It seems like I don't have my calculator, but can someone try to calculate all of that? But most importantly, guys, maybe let me say, when you substitute, don't forget that negative there so that I don't confuse someone. So let's say that negative is there, and then now we can punch on our calculators. So let's see, what are you guys getting there as you are? I'm having -3 squared plus 4 squared. I'm getting 5. This is what I'm getting. I'm not sure if all of you guys are getting that same answer. Mapaseka, are you getting that same answer, honorable member? Sidumi Lekowane.
Yes, I do get the same answer.
Okay. Remember, guys, with this type of questions, what I like is that your hypotenuse is always bigger than your adjacent and your opposite. So that means if you got a value which was less than those, you know already that it is wrong. So those are the signs which will make you to be aware whether you are doing some wrong calculations or not. So now, can you see? We have completed our right-angled triangle. I'm telling you, once that part is complete, it's going to be very, very much easy for you guys to answer the questions. So let's see. 4.1.1, let's maybe have a look at A. Can you guys see? Make sure that all that I've written, you also write it, because you might find that you get a mark for you to correctly calculate that. So also for you to complete that right-angled triangle, you might find that somehow you score some marks. So I'm not sure, are you guys ready to answer the questions, or is there someone who's got a question based on what I've explained there? So remember, guys, I'm moving a bit quicker so that I cover as many information as possible. And most importantly, today we are doing weekend extra lessons, which means you have an opportunity to study ahead. So that means the chapters that we are doing during weekdays, you will still be attending those, but on weekend, you study a new chapter. So that means during our weekdays, we will still have to do this chapter. We will still have to go through everything that we are going through. So it's going to be an advantage to some of you guys, because it helps when you read something many times, because the more you see it many times, that's how you easily learn, and that's how some of the other things make some sense. But most importantly, when you are attending extra lessons, you are in a better position to complete the question paper very quickly, because we cover as many chapters as possible. So let's see. Anyone who's got a question before we answer our questions? Guys. I'm thinking the network is poor from my side. I wonder if you guys can see my whiteboard. Can someone just indicate? Can you guys hear me? And can you see there?
So we can hear you, but we cannot see anything.
Okay, let me try something. Mapaseka. Let me quickly try to see if I can do this. I think it's still nothing. Okay, this is what I'm going to do. I'm going to quickly leave and I will rejoin. Okay, let's see. How about now, honorable members? Can you now see?
Yes, sir.
Okay, so before I got disconnected, my question was, since we are now on 4.1.1, letter A, what is the ratio for cos angle in terms of x, y, and r? Remember, guys, in case if you've got no idea, please feel free to say no idea, then I will explain. What is the ratio for cos in terms of x, y, and r?
So the ratio is x over r.
Yes, x over r. So what is the x value and what is the r value from our triangle, which is a right-angled triangle?
So it's -3/5.
Let's see. X is -3/5. I'm telling you, honorable member, by so doing, you score yourself 4 marks. And you might find that some of the marks are coming from you completing that right-angled triangle. I'm not yet confident that we are all on the same page,
Only one
guys.
who can't see on your screen.
Is she the only one, guys?
Yes,
So
I
I
can't
also
say.
cannot see.
Okay. In that case, let me quickly do something and I'll try to bring back the screen. Let me do this. So it's switched off and then now I'm bringing it back. So let's see. You still can't see. How about now? Can you see now?
Yes, sir, we can see now.
Okay. So the Maumis, this is me asking to say, is everyone understanding what I've done there? I feel like I'm leaving some of you guys behind. Mapaseka, uthulile lapho. Are we together there, honorable member, or was it you giving the answers? Sidumile, are we together there?
Yes, I'm trying, but the screen is white. I can't see anything.
The screen is gone again. Okay, let me try.
Please, can you repeat it? I didn't get it.
But What about the screen, the Umis? Can you see?
The screen is perfect.
The screen is... Did she say it's fine? Let me do this. Sidumile, I'm trying to bring it back. How about
maybe it's
now?
on my side. Maybe it's on my side. So
Okay, so this is what you can do. Quickly leave and then rejoin. In case if it does the same thing, when you leave and rejoin, it's more like you refresh your phone. So just quickly do that and come back and check if it's okay. Thank you. So, are you, hey, Kwazi the Makwazis, are you sure, honorable member, you understand what we have done there? Apelele. I see Precious is there. We also have Buddha. But you guys haven't said anything. Precious, can you just say something, honorable member? Even if you greet me, it's fine. I just want to make sure that you guys are not watching our perfect wedding that side.
We
Vuzani.
are on the same side. We are on the same side.
Okay, 100%. So that's how you answer that question. It was an easy one, but now let's try to have a look at a B. So you will realize how complicated this kind of questions can be. So can you see this one? They say 3 sine of that angle multiplying sec of that same angle. The whole of that is being divided by tan angle. So remember, guys, it is very much important that you remember the trig ratio for sine, trig ratio for sec, trig ratio for tan. So maybe let me do this. That means we have 3 being a number. What is the ratio in terms of x, y, and z for sine? What is the trig ratio for sec in terms of yx and r? What is the trig ratio for tan in terms of x, y, and r? Anyone who'd like to give it a try? What is the trig ratio for sine?
Y over R, sir, is equal to 4 over 5.
Okay, y over r. Maybe let's try to do it step by step just for today. And then on upcoming lessons, we'll just remember that if it's y over r, we just straight away take it from there as values. So what about sec? That's where you need to remember the cousins. Whose cousin is who? So what is the trig ratio for sec?
So it's hypotenuse over adjacent, which is R over X, is equal to 5 over -3.
Okay, so now what about tan? I think tan is obvious. What about the trig ratio for tan? Guys, trig ratio for tan.
So it's Y over X is equal to 4 over -3.
Okay, it seems like you guys fully understand what we are doing there. So let's try to quickly substitute. So you're saying your y is 4 over. What is r? R is 5. And then now, what is r over x? Which is 5 over negative 3. All of that is being divided by y, which is 4 over x being negative 3. So can you now see it takes you back to grade 10 where you now need to work out that. But from my side, I'm able to notice that this, it seems like it cancels with that, this cancels with that, and then you have that negative there, which is more like at the top you end up having negative 4, and then this is over. Obviously, you still have your 4 over 3 there having a negative sign. And then remember, they said you mustn't use your calculator. So it's more like you end up having negative 4, which is actually divided by negative 4 over 3. But I think let's maybe cancel those so that here we can just have 4 divided by that. So if you guys remember, this is the same as 4 multiplying this at the top, that at the bottom. So it's more like that over that. And if you remember, this cancels with that, and you end up having a 3 there as your final answer. So let's just make an assumption that we are not sure if this is the correct final answer. How do you prove it? Let's try to punch all of that on a calculator, and then if we get 3, then we know that simplification is correct. So let's see, that's how I used it. I mean, I used to do it even though they said do not use a calculator, but I would just straight away punch it and know what my final answer is, and now try to work it out. So let's see, over negative 3. I hope I get 3. Yes, I'm getting 3 when I punch all of that, which means this is correct. Is it only me who got 3, or all of you guys, are you getting the same answer there?
Yes, sir.
Is it everyone who's happy with that simplification, or is there someone who's being left behind? Tankiso, are you okay that side, honorable member?
Yes, I'm okay.
Is it everyone who's okay with that one before we quickly move on to the next question? Okay, so now with you doing that, you score yourself 4 marks. So here comes a question being 4.2, and they say, what is it, 4.1.2? They say, hence show that sine squared angle minus 1 is equals to negative cos angle. This is where it gets interesting. What makes trigonometry to be difficult is because you deal with a lot of ratios, and if you don't have a strategy of dealing with ratios, it then becomes a problem. So before I solve that, let me quickly remind you guys of something very, very much important. So if you have 2 over 3, let's say minus 7, and they say simplify this thing. The question is, how are you going to simplify it without using a calculator? This is what I used to do. I just do this thing. This is what reminds me of how to work out something similar to that. Let's try to apply it. So let's see. Since you have a fraction this side and in between, you only apply this if in between it's a sign of a plus or a minus. In this case, it's a minus. So let's try to fractionalize this on the other side. So you always say over 1. In case if you have, let's say, 2 plus 3 over 7, that means you are going to fractionalize this so that you can apply that. So let's quickly try to see how it works. So you are going to say this at the bottom, that multiplied by that. This is where that part comes in. So what is this multiplied by that? Is it not 3? That is 3. So now this is where this comes in. That multiplying that, that multiplying that. It's more like you now cross multiply. So that means you say this, it's multiplying that. What is 1 times 2? That is 2. And then you say this multiplied by that. What is that? I think is it 21? Just correct me if I'm wrong, but I think it's 21. So now, what sign do you put there? You put that sign which was used. If it was a plus, you're going to use a plus. Now it's minus, we use a minus. So that means what is 2 minus 21? I think that is negative 19. So it's more like the whole of this being 2 over 3 minus 7. It's negative 19 over 3. Let's try to punch it and check. So let's see. Over 2 over 3 minus 7. Yes, negative 19 over 3. So the reason why most of you guys struggle with the ratios is because of not knowing this. But I'm telling you guys, now that you know, you will see that it's very, very much easy to apply in any type of a question. Let's maybe quickly try to look at this. They are saying, hence show that this is equals to that. Let's maybe say the left hand side, it is the one which is sine squared angle minus 1. Let's see, what is the ratio for sine? We know it's opposite over hypotenuse, opposite being what is it? Opposite being 4 and then hypotenuse being 5. But remember, it is sine squared. That is why I'm only going to put the ratio inside the brackets and then you square on the outside. So you say minus 1. So you just substituted that trig ratio using hence, being those values there. So now let's see. This is where you apply the laws of exponents. You remember the lesson that we did early in January. We used the law of exponent to say this squared, what is it? Is it 16? I think it's 16. And then this squaring that, I think is 25. So it's more like you are having 16 over 25 minus 1. So now, can you see that you need this strategy of mind? You say you fractionalize that, meaning you are going to say that times that. It's more like you're saying 25 multiplied by 1, which is 25, and then you do that by that. What is that times that? Is it not 16? And then you do that by that. What is that times that? Is it not 25? So now what is the sign in between? It's a minus. Then what is 16 minus 25? I think, let's see, 16 minus 25, that is a negative 9 over this 25. So can you further simplify this thing? That's where I think even if you try to punch it on your calculator, examiner might not notice, even though they said do not use a calculator. Then you notice it cannot be further simplified. That means this one, it ends there. So now, before you can try to do the right hand side, let's try to check if whatever that we have done there, it takes us to that final answer. Just to test if that method works. So let's see. You open a bracket fraction, you say 4 over 5, you close, you squared, you minus 1. Yes, I'm getting negative 9 over 25. So that means you have correctly simplified the left-hand side. So you now move on to the right-hand side. Let me maybe use a red ink. So let's say the right-hand side. What is it? It's negative cos squared angle. So let's see, what is the ratio for cos? The ratio for cos, we know that it is a, what is it? It is adjacent over hypotenuse. Adjacent being x, being negative 3 over hypotenuse being 5. You still have that negative there. This 2 is going to square negative 3. I'm telling you, a negative 3 squared is equals to positive 9. Just make sure of that. So this squared, it means times negative 3 by negative 3. That's why it gives you positive 9. So that's why I'm having positive 9 there. Over that squared, it squares that 5, and that is a 25. So you now remove the brackets. You've got an invisible 1 there. So it's more like negative 1 multiplying the whole of that. It ends up being a negative 9 over a 25. So can you guys see? You've just shown that this is equals to that. So are you guys sure that you understand what I've done there, or did I leave some of you guys behind? Anyone who's got a question based on what I've done there? Mapasika, are you sure you are not lost, honorable member?
So I'm not lost. I'm okay.
But is it everyone who's not lost? Let's see. Sidumile, are you okay that side? Tangi the matankiso. Are we doing okay that side? I see Precious is there, but
I'm back, but I'm lost.
where did I lose you, honorable member? Okay, remember, this lesson is being recorded. You will have an opportunity to catch it up. I think when you watch it for the second time, you will then have a better understanding of what I've done there, because you might be lost because of not knowing how to work out fractions using that, which is something that you will need to quickly learn so that you can easily understand what we've been doing there. So maybe let me quickly move on to the next part and say, when you catch up, honorable member, just make sure that where you get confused, you note it down. I'm telling you, when you catch it up, everything it's going to make some sense. You might not know how to ask now because possibly you are doing this chapter for the very first time, but maybe very, very quickly, let's try and have a look at that. Simplify the following expression without using a calculator. And this is cos 30 degrees multiplying tan 60 degrees plus cosec a squared 45 degrees. Can you guys see? It gets even more complicated. So that is why it is important that you don't miss any of my lessons, because in each and every lesson, the umis, there is always something to learn. So maybe for the sake of time, let me try to do this on my own, and you guys will ask me a question in case if I'm losing. So when you look at these, try to have a look at those angles. Can you see 30, 60, 45, 60? These are what we call the special angles. So let's see. I think the special angle for a 45, we have 1, and then we have square root of a 2 there. I'm just not sure. Let's see. This one we had 60 there, and then we had 30 there. I think we had 1 here, and then we had square root of 3 there, and then we had 2 there. Just make sure that in case if I'm wrong, you correct me, because you need to know that one by heart. So can you guys see? Now I just need to know what is the ratio for cos. Cos is adjacent over hypotenuse. But now, which angle are we referring to? We are referring to that angle of a 30. So maybe let me do this so that it's easier for everyone to understand. Because sometimes that one being combined, it's confusing a lot of you guys. So that means you need to separate those angles and have a special one for 30, 60, and 45. So let's see. For cos 30, we focus on that. And we say cos is adjacent over hypotenuse. What is adjacent? Adjacent there is square root of 3 over what is hypotenuse? It is that 2. And then now, tan. Tan is tanungwa, opposite over wait. I think I made a mistake there. I'll need to decide between these two, which one is for 30 and which one is for 60. Maybe let's say this is the one for 60. I will write that 60 there. 60 degrees there. So can you now see we've got a special angle for 45, for 60, and for 30. And then we've looked at the one for 30 where adjacent is 3. Adjacent being that side square root of 3, hypotenuse being that 2. So that's why we said adjacent over hypotenuse. Then we are now on tan. Tan is opposite over adjacent. What is opposite there? Opposite, it seems to be square root of 3 over a tanua, opposite over adjacent. So that means it's 1 there. Then you say plus, you come to this one, cosec 45. So you need to remember what is the cousin for this one is for a sine, and then sine we know is opposite over hypotenuse. So that means it's going to be hypotenuse over a opposite, being the ratio for cosec. So now it's cosec looking at an angle being 45. So this is where we look at. So that means inside your brackets, and you're going to square it because of that square. Then you are going to say what is hypotenuse for this one of special angle of 45? Hypotenuse is square root of 2, and then now what is the opposite? Opposite, obviously, it is 1. Then you move on to the next trig ratio. Can you see? You're having sine there. Sine what? Sine of 60. That means you focus on that one. Sine is opposite over hypotenuse. So what is the opposite of that angle? It is square root of 3. What is a hypotenuse? Hypotenuse is 2. I'm telling you guys, a trigonometry, especially this part, it's not difficult. It is just confusing. So that means you need to know which side is which. You need to know the special angles. You need to know the reciprocals, and you need to remember their ratios, because if you don't, you are going to get everything wrong. And again, you need to be very good with dealing with the ratios. I'm trying to have a look at that, and I notice it could be something a bit tricky. But if you guys remember, beginning of last month, we studied what we call the surds, being the square roots, where we said if you multiply a square root by a square root, you just say square root of whatever that is inside, multiplying each other. This times that obviously is equals to 2. So the question is, what is 3 times 3? 3 times 3 is 9. That is why I'm going to edit it there and put 9. But also, what is the square root of 9? Is it not 3? So the square root of 9, it is 3. That is why we end up having 3 over 2. So that means if on your calculator you punch square root of 3 space times square root of 3 is going to give you 3. And then now, that's when you can move on to this one. Remember, the loss of exponents, meaning that by that, and then that by that. So obviously, that squared is going to remove that square root. So it's more like you are having 2 over what is 1 squared. It is just 1. And then you do the same there. That squaring that, and that squaring that. You know this 2 removes that. So that's why you're going to have 3 over what is 2 squared. That is 4. So you still have 3 over 2 plus you just want to multiply those. What is this times this? I think that is 6 over what is that times that? I think that is 4. So can you now see, this is where you now need that, where you say this times that. What is that? Is it not 8? Okay, if it's 8, what is this times that? I think that is 12. And then what is this times that? I think also that is 12. What is the sign in between? It is that same sign there. What is 12 plus 12? I think that is 24 over 8. If you can try to further simplify this, I think 2 goes how many times in there? I think it goes, is it 12 times? Yes. And then 2 in there, it goes how many times? I think it's 4 times, isn't it? And then it seems like you end up having 12 divided by 4. And I think that is 3. Jesus, I wonder if this answer is correct. But guys, even though I was talking to myself there, did you all understand what I've done there? Does it make sense to everyone, or have I lost some of you guys on that one? Because one thing for sure, you can get lost easily. That's why you need to understand how to deal with fractions. And I'm telling you, Precious, someone might be in grade 12 feeling like this is difficult, but trust me, this is grade 10 stuff. So that is why when it comes to my lesson, I don't really care that much whether you are in grade 12, 11, or whatever. You could be upgrading. What matters the most is that the moment you don't understand trigonometry, I realize it could be because of you not knowing how to work out the ratios. But I'm pretty much sure that everyone knows the ratio for cos, the ratio for tan, the ratio for cosec, the ratio for that. Once you've substituted, going down, that's where it gets difficult. And it's not because grade 12 is difficult, it's because you are not confident with working with the ratios. Guys, anyone who's got a question based on what I've done there before I quickly wrap up my lesson for today with that question having 2 marks? Sibusiso Maham, are you okay that side, honorable member? But
Yeah,
wait,
fine.
Precious, can you say something, honorable member? Are you okay that side? Utulile.
Yes, I'm still okay. I'm still following like everything. I understand. It's clear.
I'm suspecting you are watching Date My Family that side. Precious, I don't trust you, honorable member. I have this feeling that She's watching Date My Family. That Mapasika, are you sure you're not watching My Perfect Wedding that side? I heard something like, this was our perfect. Okay, it seems like we are all on the same page. But remember, guys, do not worry that much. If it feels like you are not understanding anything, you are blank, remember, what you are attending today is what we call weekend extra lessons, meaning what we are doing today is only for those who attend weekend lessons. We are still going to do this exactly the same thing that we have done. We will still do that during the weekday lessons. So that means on the weekend lessons, we will then start something completely new. So it's an advantage because you study ahead. Okay, so let's see. Now, 4.3 being our last question, it says solve for theta and then correct two decimal places. And also with capital letters without using a calculator. No. They just say solve for angle theta to two decimal places. If 4/3 sine angle it's equals to cos 37 degrees, and that angle theta, it is between 0 degrees and 90 degrees, which is an indication that whatever answer that you get as you solve for angle theta, it has to be between 0 and 90. That's when you know you've done it correctly. But I'm telling you guys, someone might get confused by seeing the sign and whatever there. But this is what I always say. This is what we are looking for. Let's say that is our diamond. So that means if this is the diamond that we're looking for, you need to remove the stones around that. If maybe there is water around our diamond, we need to remove the water. And you can do those step by step. Most importantly, remember, this thing is just a number, because you can easily punch this on a calculator and you get a number in a form of a decimal or in a form of a ratio. So don't get confused by that. It could have been tan maybe 34 degrees, or maybe sec 39 degrees. If it's sec 39 degrees, you know it's 1 over cos 39 degrees. Then you punch it on a calculator, it gives you a number as a decimal. So don't get confused by that cos 37. Let's remove the water. This is the water. We want to get to our gold. How do we remove our water? Why can't we just divide by that water there? Remember, whatever that you do on the left, you also do on the right. Why did you do that? It's so that this cancels that. Can you see? We are now getting closer to our what is it? Diamond. So it's either you can decide to punch all of this on your calculator and get a number which is a decimal. So let's say maybe I don't have a calculator for now, then I'm going to write it as that, but you know in your head that this is actually a decimal. So we have removed the water which was around the gold. So now this is the gold that we're looking for. We need to remove the soil. So how do you remove the soil? This is what you had to do. You had to say you divide everything by a sign. But because it's a trig ratio, this is not how you remove a trig ratio. That's why they say you do that one of the second function. So that means the angle, it's going to be the second function or arcsine of the whole of that being a decimal, which I couldn't punch because assuming that I don't have a calculator. So you just punch all of this. I'm telling you, you might find an answer which is between 0 and 90. Let's see. What are you guys getting that side? So shift, sign, a fraction button, cos 37, close at the bottom, open, it's actually 4 over 3, and then you go to the side, then you close. Hey, I'm getting 36.79, but remember, they said correct to 2. That is why I can maybe say this is 36.80. Maybe let me write it as it is. It's 36.7966394.6. So when you correct it to 2, that adds up to that, and then it makes it 10, and then 1 adds up to that, then it's 36.80. So that's how you easily solve that. And guess what? By so doing, they just give yourself 2 marks. Seems like it's a lot of work, and it looks like it doesn't worth 2 marks, but it is that much easy that it's worth 2 marks. I'm not sure. Anyone who's got a question, guys, because on our next lesson, I'm telling you, we are now going deeper. So you might need to catch up on my first lesson, or you might need to make sure that you watch the same lesson again. Anyone who's got a question before I sign out? Precious, uyizwile ntombo, uyizwile ukuthi kwenzeka ntoni apha. Sidumile. Bantu bakithi, sisonke lapha. Mapasika, konke kuhamba kahle lapho. Aphelele Vuzani, sisonke.
All is clear, sir. All is clear.
Umi the Maumis, can you confirm for me, honorable member? Is all good that side?
Hayi semele ngibheka ama-recordings yo. But-ke ngizoba right.
Yebo. Ungathi ngiyavuma ukuthi hey, ungathi kusasoshuba la. Kusho ukuthi umele ubeke ama-recordings. Uyakwazi ukuthi uzwathola kuphi? Sidumile. Kwazi namakwazisi. Are you okay that side, honorable members? Zibuda maham. Konke kuhamba kahle lapho.
Yes.
Ngoba ngiyavala manje. Manje ngiyavala. Ngiyalivala libandla lakaNkulunkulu manje. Angazi ukuthi bantu bakaNkulunkulu bayangivumela ukuthi ngivale leli bandla le. Let's see. Precious, uyangivumela ukuthi ngivale elibandla lakaNkulunkulu namhlanje?
Yes, you can close, but where to get the recordings?
Okay, so I think I'll send a link to our homepage. I think some of you guys are added there. There's a link or a group which is written homepage. You will see 2023 recorded lessons, 2023 videos and audios. That's where you catch up life sciences and geo, and also physical sciences. There's also a online library timetable, grade 10, 11, and 12 tests. That's where you guys write our tests. Just in case if you are not in that group, I'm going to post it soon after this lesson. But most importantly, guys, the code for today's lesson, I think you guys can just type, just comment in the group 412. What is the code? So this is how your parents can track if you guys are attending lessons or not. So just in case if they say Kwazi the Makwazis, is honorable member attending lessons, then we are able to easily refer to previous lessons and check if you have commented with whatever the code of the day was. If you do not comment, After 3 months, if we try to check who has been commenting or who has been attending and we don't find your comment, it's more like you did not attend. If your parent tried to check and they don't find you commenting, even if you attended but you did not comment with the code, it's more like you did not attend. So guys, thanks very much for joining. My name is Desmond, and I'm out.